Good morning, everyone. I'm Shasinlo Kent, scientist from Central Groundwater Board, and I'm currently posted at State Unit Office, Shillong. So today I'll be presenting on this topic, hydrogeology of northeastern states with special reference to springs. So basically, I'll just go just to give some basic introduction to hydrogeology and then the different type of springs found in northeastern states and the past few years that we have carried out some few spring studies. So I will just show that one. So to start with, I think yesterday sir has already explained those basic what is springs. So just to get a review of that one, I'll just start with. So yesterday I think sir what has already explained what is spring. So we know that spring is a concentrated discharge of groundwater appearing at the ground surface as flowing water naturally, as you can see in these photographs. All these photographs are from northeastern states. So we can find in actual field condition is like we can find different types of springs in these conditions. So yeah. So we already know that it is a focused discharge of naturally occurring groundwater on the Earth's surface, as you can see in this photograph. So why spring? Like in northeastern states, why spring? Why we are giving more importance of these springs? Like especially those who are from hilly states or hilly region, we know that this is the lifeline for the people of the people who are living in hilly region and are completely dependent on these springs for their drinking purpose, for their domestic use. So and also it is the only source for all uses in those hilly region villages. And then apart from that one, we can say that it is the main feeder of mountain or hilly rivers, because here in northeastern state, except Arunachal, we don't have snow-fed rivers. So mostly from spring-fed rivers only. So yeah, we can see in this photograph how important spring is. Like in just a small spring, like people just line up with those buckets and to fetch water from these springs. So this is how spring is very important, especially in the hilly region of northeastern states. And also, like people used to construct this storage chamber, and then the water tanker used to come and fetch water, and then they used to sell it to the people, especially during lean season. And also in some parts, like people use it for irrigation purpose also, as a spring, as a source of irrigation. And why there is a need for spring studies in northeastern states? Before it is too late, I think now also we can see that there is a drying up or decline in spring discharge when we compare with the past 10 or 20 years. And some of the water source, like spring source, are slowly getting dried up, or so there is an issue of source sustainability. And because of this impact of climate change, we can say that it's very important before it is too late to go for spring studies. And you can see in this image how springs are slowly getting dried. Earlier, like past few decades, it was perennial spring. Now it is slowly getting dried up, as you can see. Though there is some permanent structures, like now when we go during a lean period, it's almost dried up. And in some places, it's almost dried up. And just wanted to share this. This is in Nagaland. So last year I did some study in Nagaland. So these springs during monsoon or post monsoon, the water is fully covered in this area. But this is like in the month of February. The water is like it's too very less. And this granny, she used to fetch water for 3 hours for just 2-3 buckets. So that is how it is slowly depleting the spring source. So that is just a recap of yesterday's and how springs are very important. So I will, to start with my presentation, I will go with this introduction to hydrogeology. I'm sure some of you might be aware of, already studied geology, hydrogeology. But just because when it comes to spring study, hydrogeology plays a very important role. So what I feel is like, go to the basic, and if you grab some basic idea on hydrogeology, I think you will later on it will be applicable to your project and all. So first I will go to the introduction of hydrogeology. So what is groundwater? Like in a very simple, the water that is found beneath the Earth's surface It's as simple as that one. It's a groundwater. But in like when we explain it in a more technical term, we can say that those water which fill the pore spaces between grains, like in bodies of sedimentary or clastic sedimentary rock, or the filling cracks and crevices or fractures in like in hard rock terrains, we call those as groundwater. And groundwater, we can see groundwater in the form of like rain well, duck well, or in the form of this hand pump or bore well, or like springs. So all these are groundwater. So the water that lies beneath the earth's surface is known as groundwater. So what is hydrogeology? So in a very simple term, the study of groundwater is known as hydrogeology. But when we like explain it in detail, like study of groundwater, which comprise of how the water is getting inside the subsurface, that we call as recharge, and how the water inside the subsurface flows, that is through the aquifer. We call that the aquifer zone where the water exists, and how the water and the soil and the rock interacts, that is the geology. So it comprises of the chemical, physical, and environmental characteristics. And hydrogeology, like it mainly deals with the distribution, the interaction, and the movement of groundwater in the Earth's surface and in relation to geological environment. So this is just a simple sketch, like how the study of groundwater involves, like how it is getting recharged and how it is flowing, and then how it interacts with the surrounding soil and rock, and then it comes out in the form of springs, or like it gets discharged to the streams. So what is its importance in spring studies? Through these hydrogeological studies, we can know the regional and local geology of that particular area, the structure, the topography, and the aquifer system and the characteristics. Like the aquifer system and the characteristics. Why? Because each spring has got its own aquifer system. So like say when we talk about spring shed management, like without not every spring is feasible for spring shed management, because it depends on the aquifer system, the aquifer characteristic in that particular area. So before going for spring shed management, we have to know like the aquifer system existing in that area, the geological conditions and the structure. So it's very important before going for spring shed management. These are the So coming to the next, that is the vertical distribution of subsurface water. So when we say like this is just a vertical subdistribution, but when we just drill, or like when we consider the subsurface starting from the ground surface till some level, it can be classified into two zones, that is zone of aeration and zone of saturation. And zone comprised of soil water zone, intermediate water zone, capillary zone. This is you don't need to remember all those things, just to show you like how the vertical distribution of subsurface water exists in the subsurface. So the zone of aeration, it comprises of those three zones, and zone of saturation, it comprises of like when the water is fully filled in this subsurface, we call as the zone of saturation. And the top layer and the topmost layer we call as water table, where fluid pressure is equal to the atmospheric pressure. We call those as water table. And where all the pores are completely filled with water, we call as the saturation zone. So so to know this hydrogeologic study, we have to know like what is aquifer. Aquifer is like the water-bearing formation that readily transmit water to wells and spring, or in other words, we can say that it is an underground layer of water-bearing formation, like you can see this sketch, where it can be through permeable rock or unconsolidated materials from which groundwater can be economically extracted. Where there is enough water and it can be economically extracted, we call those as aquifer. Or like we can say that a rock in it that will yield water in a usable quantity to a well or a spring. So it can be like in a hard rock, we can see in the form of fractures, or in like in this one, in soft rock, we can see in like where the water fills the pore spaces of the intergranular pore spaces. So there are other type of aquifers, but these are the two main aquifer systems, like unconfined aquifer and confined aquifer. So and what is an unconfined aquifer? An unconfined aquifer is like the one where the aquifer rests on the impermeable strata. This is an impermeable strata where the water cannot penetrate. So when the water like exists in this form, we call as unconfined aquifer. And when there is an impermeable strata overlying and underlying, and in an how to remove this one? Okay. Yeah. So when there is an impermeable strata overlying and underlying the aquifer zone, we call that confined aquifer. So these are the two main aquifer systems. Apart from this, there is semi-confined or liquid confined aquifer, and then perch aquifers. But if you know like these two main, I think it is enough. So going to the next, that is the aquifer properties. So to know the aquifer system, we have to know the aquifer properties. Like the aquifer properties comprise of like porosity, permeability, specific yield, and specific retention, storativity, and storage coefficient, and transmissivity. So we will go one by one just to show you the basic things. So porosity, we all know that there are two type of porosity. One is primary porosity, where it is formed during genesis or the formation of rock, and the secondary like form after the genesis of rock. That is like the fractures, caverns. Whereas the primary is like the intergranular spaces. That is the we can see in the form like sand, clay, as you can see in this image. So these are the two main porosity type. So just to show you like in a more simplified manner, like say if we take one glass and then put sand, gravel in that glass and then add water, and then the water gets filled inside this pore space. So to know the porosity, like we can just calculate like water added, how much water quantity is added, and then the volume of this glass. So when we divide this water added divided by the volume of glass, we can get the porosity percentage. That is as shown in this slide. And the permeability. So permeability, it is like the ease where water can move through these interconnected pore spaces. So we can see that this one is not connected. So though it is porous, but it is not permeable. And this one is like highly connected, so it is porous and permeable. So I'll just like the earlier example, I will just show how we can say that it has got a high permeability or low permeability. So when we put a funnel and then put some, this one is gravel, and pour water, the water suddenly gets discharged, right? So it has got a high permeability because there is interconnected pore spaces. And if we put sand, the time that it takes to the water to fully drain, it's slightly lower than the gravel. But when we put put clay in a funnel and put water, it takes lots of time. So it has got a low permeability. So, but we can say like clay has got a high porosity, but it has got a very low permeability. So coming to the next, that is specific yield and specific retention. So specific yield, like it represents the amount of water that can be drained from the saturated zone of an aquifer. And specific retention, like it represents the amount of water that is retained in the aquifer material and cannot be extracted or easily extracted on pumping. So I think if you go to the next slide, you will better understand. So specific yield means like in a saturated sandy gravel, say if we put that one like earlier, and then drain that sandy gravel, and then the drain water, that quantity, how much water has been drained, then the specific yield, it means like the water drain is like this much and the volume of glass is there. So if we divide with the water drain and the volume of glass, we can get the specific yield. Whereas specific retention is like the water that has been retained, like the water that is like if we drain it and then the little amount of water that is being retained in this material, we call those as specific retention. So it can be calculated like volume of water retained is like weight of moist sandy gravel minus weight of dry sandy. Like that gives the volume of water retained. So volume of glass is this much, then specific retention is how much it has been retained. So like you can calculate based on that one. So this is like if we compare with this specific retention and specific yield, we can say that gravel has got more specific yield. So when we talk about aquifer, like the more the specific yield, the better the aquifer. I mean, it's what is that? It has got more. It has got more specific yield. I mean, what do we call this one? The aquifer system is better than the like having more specific retention. If you have more specific retention, then the aquifer, it doesn't give much water, right? If you have more specific yield, then the water, say in case of spring, if that particular spring has more specific yield, that means it will give more higher discharge, and it will even in the lean period also it will give more discharge. So just to show that one. And this is like specific storage. So similarly, like specific storage or storativity. Storativity is almost similar to specific yield. But when it comes, like technically, if we define it, specific storage, then the volume of water released from per unit volume of aquifer per unit decline in hydraulic head. It's known as the specific storage. And storativity we can define as the volume of water released from per unit surface of aquifer, this entire aquifer, per unit surface of aquifer, per unit decline in its hydraulic head. So based on this calculation, like we can say that the storativity ranges, for confined aquifer, the storativity ranges from 10 to the power minus 5 to 10 to the power minus 3. So in an unconfined aquifer, the water released from storage is mainly due to gravity drainage and not due to the compressibility of aquifer material. As I have earlier shown the two types of unconfined and confined aquifer. And in confined aquifer, like the storativity is a result of compressivity of the aquifer and expansion of the water content. And the next one is transmissivity. So transmissivity is like the measure, it is measured by the rate of flow of water under unit hydraulic gradient through a vertical strip, as you can see in this sketch, of aquifer unit width and extending through the entire thickness of saturated aquifer. And it can be like defined as transmissivity is equal to Kb, where K is hydraulic conductivity and B is the thickness of the aquifer system, and it is the unit is in meters square per day. So this is just like if there is the higher transmissivity, like how it is actually in actual field condition, how it exists, like when the water is pumped out. Like say in case of coarse grain material, if it is a coarse grain material, it has got a higher potential aquifer system and it has got a huge discharge. I mean, so even if it get pumps like this cone of we call this cone of depression, it doesn't get I mean, drawdown is much lesser and this one is a bit wider. And whereas in case of finer grain material, where the aquifer potential is much lesser than the coarse grain material, the cone of depression is much deeper, and then it is not that wide. So this is just a drawdown comparison. And the higher, this one is like low transmissivity and high transmissivity. Like if it is, say transmissivity is high, then the cone of depression is wide, radius of influence is large, or hydraulic gradient is low, hydraulic conductivity is higher than the this one, low transmissivity. Just comparison. So basically, like occurrence of groundwater, it can be in soft rock or hard rock. So when it comes to soft rock like is like in alluvium, or we can say that sand, gravel, pebble, or sand, clay, silt. Those are the soft rock, and you can see that. Like earlier, I have explained like unconfined aquifer or confined aquifer. If this can be in soft rock. This can impermeable strata can be a clay zone. I mean, beyond that one also, it can be a basement rock also. And occurrence of groundwater in hard rock. So in hard rock formation, we know that it's a fully compact cemented rock. So in this kind of rock formation, the aquifer exists in those cracks and crevices or fracture zone. So like when we talk about springs, in this you say in Meghalaya or even in Nagaland, I mean apart from those soft rock terrain, like I think majority is covered with hard rock terrain. So mostly you can find the aquifer system exists in this hard rock. I mean in the form of this fracture zone. So when this fracture zone encountered this surface, then the water naturally comes out. So we call those as those kind of springs as fracture spring. So these are some of the we can see clearly that there is a fracture zone, and then the water comes out. So these are some fractures springs. So depression spring. So depression spring is usually like when there is the water table. When it touches. I think yesterday Sir has already explained, but in actual field we can see that say this one there is a the undulatory terrain, and then whenever the water table touches the surface, the water naturally comes out. So you can see in this type of springs usually in hilly undulatory terrain. So we all know that in northeastern region the main drainage are Brahmaputra River and Meghna, and despite heavy rainfall, we all know that we receive good amount of rainfall, but during lean period there is an acute shortage of drinking water. People are facing those acute shortage of drinking water, and the hill ranges occupy about 70% of the total geographical area. So we can say this is just a distribution of hills and plain. So major part of these northeastern states are covered with hilly region, and in hilly region we all know that people are dependent on springs for their drinking domestic purpose. And the geological setup, like it ranges from Precambrian, like the oldest rock formation, till the recent one. So there are 5 major geotectonic divisions like shield area, platform area, shelf area, mobile belt, and the 4 deeps. So for northeastern state, the hydrogeological setup can be classified into 3 formations. That is unconsolidated formations, semi-consolidated formation, and consolidated formation. So unconsolidated formations are those where it is a non-cemented, loose formation like sand, gravel, pebble, which I have shown earlier, and semi-consolidated formation are where the formation is like fully compacted, cemented, like say quartzite, granite, those kind of rock. No? So and semi-consolidated, it can be of tertiary formation where it is not fully cemented, or where it is not fully compacted like hard rock. So in between this unconsolidated and semi-consolidated, we call that one as semi-consolidated formation. So this is the hydrogeology of northeastern states. So northeastern states, we can see that we can classify it into unconsolidated formation, especially in the Brahmaputra Valley and in some part of Tripura, Manipur Valley, especially in the Imphal Valley. And those are comprised of unconsolidated formation. And semi-consolidated formation, especially in the tertiary formation, like shale, sandstone, we can see in some part of Meghalaya, and then Assam also, and in Nagaland also semi-consolidated formation. And consolidated formation, like where there is a hard rock formation exists in underlying in those areas, we call those as consolidated formation, where even the aquifer system is, the potential is much lesser than the unconsolidated formation and semi-consolidated formation. So I'll just go ahead with that. So CGWB, we have monitoring station in different hydrogeological formation to determine the state of groundwater. Like we used to calculate the dynamic groundwater resource using those groundwater monitoring stations data, and to enable the establishment of cause of effect relationship and monitoring collection of water samples are also carried out periodically. This is like the distribution of groundwater monitoring in different hydrogeological formation in NER. So we have around 650 monitoring stations. So I will go one by one, like the different states or northeastern states, the hydrogeology and springs exist in those. So to start with, I will just go with Meghalaya state. So Meghalaya also comprised of this consolidated and semi-consolidated and unconsolidated formation. We all know that Meghalaya is like the geology is very complex. We can see the recent till the Precambrian till the recent formation, and for consolidated formation, we can see in this map that most of the area is underlain by consolidated formation, which is the hard rock, and it comprises of quartzite, intrusives like Shillong group of rocks, and then carbonate, non-carbonate sedimentary rocks like limestone. Those hard rock formation, and then semi-consolidated formation, especially in the Garo Hills area, we can find some sandstone, siltstone, shale, and interbedded with the coal seams. And unconsolidated formations, mostly in the, especially in the Garo Hills also. This one is also in, and then valley portion area where it comprises of sand, silt, gravel, pebble, and the highest aquifer potential, good aquifer potential exists in this unconsolidated formation, which is in Garo Hills, especially in southwest Garo Hills district. And this is the principal aquifer and groundwater exploration studies carried out by CGWB. The green dotted one are those exploratory wells. So we have found that 8 principal aquifers in this Meghalaya, which like alluvium, sandstone, limestone, intrusive, granite, quartzite, schist, and gneiss. And this is just exploration data. So through this exploration, we have prepared this one 2D aquifer section. So this is just an example, like in southwest Garo Hills district. These are the aquifer potential zone, where, and then this one is a shale where the aquifer potential is very less. So in this, we can see that there is some small thickness of alluvium, or we can say that soft rock. And beyond that one, there is semi-consolidated formation, which comprises of sandstone and shale. So, say in case if we find springs in this area, so say for example, if I find springs here, then where to put those recharge structures? Say if I put recharge structures here also, right after topsoil there is clay. So even if I construct this trench, will it get recharged to that aquifer system? I mean that spring aquifer. No. So it's very important to know the hydrogeological conditions, the aquifer system existing in that area, and especially this 2D section will help in preparing those where to put those structures. This is like in hard rock, say in Riboy district, we can see that it is mostly underlain by quartzite, granite, gneiss. So in hard rock, there is this fracture zone. So from those fracture zone, the water, the water comes out. So we found that in quartzite formation, there is more fracture zone than the granite gneiss, and the aquifer potential is much higher than the granite when we compare with quartzite and granite in Riboy district. And this is like 2D aquifer disposition in Greater Shillong area. So in Shillong area, it's underlain by quartzite and some this intrusive rock, that is Khasi greenstone or epidiorite we call. So we found that this is non-pure is on the upper part, Shillong, and then if we come towards this Nehu, the groundwater flows in this direction, and then the aquifer potential is much higher than in those Nehu area than the upper Shillong area. This is another section, starting from Lightcore till Maudiang. So springs of Meghalaya, like in Meghalaya, we can see so many. Some good discharge spring, discharge of springs. We can see some, and then in some very less discharge also. So it depends on the aquifer system existing in those areas. So we can see some fracture springs, as I've shown earlier in this, those photographs also. This one is in Tirsad, Amlaram, and then this one is in Riboy area. We can see some depression springs, like depression depending on the topography, the depression springs. So usually fractures and depression springs, you can see, the majority is mostly of these two types. So apart from that fracture depression spring, we can also see some contact springs in Meghalaya. say in this is like massive sandstone and then splintery shell. So in between, in contact between these two, the water comes out naturally, which is a contact spring. And this one is in Jowai area. You can see like this is sandstone. You can see some pebbles. So this is, we call those as conglomerate. So in contact zone of this massive sandstone and then conglomerate, the water is coming, and the people consider this spring as a very sacred one. So to monitor this spring also, we have to, take out our shoes and then monitor this one. So yeah, just to show some contact springs. And this one is like, it's in Riboy, massive quartzite, in contact between massive quartzite and this is weathered zone. And we can also find some karst spring in Meghalaya, especially in those Sora area. So I think Sir has already explained different types. So this I'll just show like how, what are the different type of springs found in Meghalaya, and then we can also find hot springs in Meghalaya, like in Jakram spring, Jakram hot spring, and then Rasabilpero hot spring. In Jakram hot spring, that temperature is much higher than this Rasabilpero hot spring. Where in, I think in Rasabilpero hot spring we can differentiate the temperature only during, especially during winter season. So CGWB has carried out some just basic study of springs in Meghalaya. Like we have invented some 160 number of springs, and which are mainly of fracture, depression, and contact springs. And these are the like district-wise discharge variation. So most of the springs, like the discharge varies from like 10 to 100 milliliter per second. Only in some few, just one or two springs, like the discharge ranges from 1 to 10 liters per second. So we can say that when we compare with Menger's classification of spring, most of the springs falls in this 7 magnitude, like 60% of those springs that we have monitored, it falls in this 7 magnitude. So discharge variation, like during pre-monsoon, in that same spring, like how the discharge varies, say this one is in Amlaram, during post-monsoon, huge discharge, but during pre-monsoon is very less. So this is how like the spring discharge varies over the months. So this is like just during 2016-17, during our NECM studies, just 1 year we have monitored around 16 springs, I think. So I have just plotted like, so each shows different variation of spring discharge, right? So from this, I think yesterday Sir has already explained, like from the spring hydrograph, how can we interpret. So as I have mentioned earlier, not all the springs are feasible for spring shed management. So through this spring hydrograph, like can we get some idea, like, okay, fine, this is this spring is feasible, it needs some spring shed management program to be carried out, or like this spring doesn't need spring shed management. Can you make out some, seeing this hydrograph, can you make out some those things? This one, yeah. Yes, yes, yes.
I think it's perennial and also it's
Yeah, yeah, you are right. So this one is perennial, but it doesn't have, though it, it received good amount of rainfall in Riboy, it received good amount, like especially during June, July, August, but there is not much variation, right? That means this aquifer system, like it has got a, like the storativity is not that high, or the aquifer of this spring is like, it doesn't have much capacity to hold the water and then transmit it, right? It has got just a constant, whether it rain or not, it's like almost constant, right? So even if we construct these artificial structure, recharge structures, it would have much impact. However, if we see these springs, it has got a huge variation. It is perennial, but it has, it shows that it has got a huge storage capacity.
but sir, if we have suppose an orange line,
Yeah.
which has much variation, only that spring is there available in a particular area, and many people, like domestic people, are dependent on that spring.
Yes, yes.
So we will take measures for to revive this spring, or we will leave it.
No, no. So
Even
it,
if it has lots
Yeah.
of variation.
so it has got like lots of variation. That means it has got a huge storage capacity. So, but in say in lean period, it's the discharge decrease, right? So if we construct in this kind of spring, if we construct artificial recharge structure, then it will have much impact on the spring discharge of this particular spring. So, so in this kind of spring, we can go for spring shed management, but not in this kind of spring, where it is, yeah. So this is like we have also monitored like daily, almost daily monitoring. So we can see just to show that the rainfall and the spring hydrograph. So this is like the orange is like it is the rainfall data, and then this one is spring discharge. So we can see that immediately it doesn't get recharged to that spring and spring aquifer, and then the discharge gets increased suddenly. It doesn't show like that. At least it has got some gap. Say in April, like there is huge rainfall, especially in May, June, but the peak period is after like in August month only. So it takes time for the spring aquifer to get recharged. And so this is just one example which I used to show in most of my presentation. Like this was photographs taken in 2016 during our NECUM study, and people were, this one is a huge spring discharge, 4 or 5 outlets. But in 2022, like the locality in that Dorbar, they call us like suddenly the spring discharge is completely dry. So they want us to come and visit and then find out what could be the reason. So when we inquire about it, we found that in that particular spring, I think sir has already explained this one, but this is very similar to that case only. So in that particular area, there is 2-3 bore wells nearby that spring. So it is tapping the same aquifer. So whenever those 2-3 bore wells, if they pump continuously for 5-6 hours, that spring discharge gets completely dried up. So that is why there should be some regulation to be implemented in those spring area, like within the periphery of that spring, no borewell should be constructed or something like that. Yeah. So coming to the next, that is hydrogeology of Nagaland. So Nagaland, we all know, like it's mainly comprised of sedimentary rock, except in the southeastern part, where you can find some ultra basic rock. Most of it is mainly of barrel formation or descent formation, where it comprises of sandstone and shale. Yeah, so mostly the groundwater in this area is under semi-confined to confined condition. And in Dimapur Valley area, it's like unconsolidated alluvial plains. So this is the hydrogeology. We can find like the alluvium, the Disam, Tipam, Suma, Beryl, and Disam formation in Nagaland, and ultra basic and basic rock in the southeastern part. So we have done some studies, and we found that in Dimapur Valley, it's like unconsolidated formation, and the aquifer potential is also quite high when we compare with other parts. And this is like the 2D section. So we can see that sandy aquifer or like confining layer and then tertiary aquifer in this Dimapur area. This is another section. And this is like one huge spring where 2-3 villages are dependent on this spring. And this is a depression type of spring where like there's a steep slope. So when the water table touches the surface, it's the water like it comes out. So it is a depression type of spring. And we have done some spring studies in Nagaland also. A few springs, we just did some inventory and then monitored those springs. So we found that spring, when we compare with Meghalaya spring and Nagaland spring, the spring discharge is very less compared to Meghalaya. Like in Nagaland, you will find that the spring discharge ranges from 0.001 LPS to 0.01 LPS, which is very less, but people are very much dependent on this spring, and it's getting dried up in some places, like in Wokha district, it's getting dried up. And this is this is also a fracture spring in between this sandstone, intercalation of sandstone and shale. And this one is like, so in Nagaland, most of the water source are from springs only. The water source that is being supplied to the village. But the discharge, when we see the discharge, is very less. So this is just one, during 2019-18, we went and visited one spring source where the PHE department, they were planning to supply it to the, one district headquarters, which is in Longlang. So we found that like we have done some inventory only in some few districts, so we can see that this one is in LPM, liter per minute. So it's very safe impact, 0.06 liter per minute to 8.58, which is very less. And most of the springs in Nagaland falls under this 7 magnitude. And there is also a salt spring. We can find some salt springs in Nagaland, where the local people, they will fetch water from that one, and then they used to boil it and make salt cake like this. No? So this, so in they used to sell it. So in Assam also, you can we call those kind of springs as brine spring also. So you can find brine spring in even in Assam, in Arunachal Pradesh also. So this study was carried out last year. We have selected like 4 blocks of Kohima district, and then we have done some inventory, around 100 springs. We have done some inventory, and then we found that the spring discharge like ranges, as I have mentioned earlier, like 0.0004, which is very less. But these the springs that we have invented, like where the village are completely dependent. So this is how important springs are in those hilly areas. No? Though the spring discharge is very less, but yeah, it's very, and the geology, you can see the shale, sandstone, intercalation of shale and sandstone. So it's like not that very stable when we compare with others, as in Meghalaya. So to go for this spring shed management, we have to consider the geological condition, because just blindly we cannot construct trenches in those loose formation, right? Because it's highly susceptible to landslide also. So considering this landslide susceptibility map, it's very important when we go for spring shed management, especially in the state of Nagaland, because it's highly susceptible to landslide. You can get this landslide susceptibility map for the entire northeastern state from GSI website. So whenever you are planning for this spring shed project, I think this landslide susceptibility map is also very important. And just to see like whether this lineament has got a, spring location distribution, we found that it doesn't have much correlation with this lineament density map. And we also did some groundwater exploration study. For the first time, CGW has constructed did some groundwater exploration studies in Nagaland, in Kohima district. And in one, it was quite interesting that we found huge discharge in Kohima district, where the formation is like sandstone shale. Shale, completely shale. We got the discharge like around 12 to 13 liter per second in that borewell. Na? So even in those kind of formation like shale, sandstone, the discharge was quite high, which is around 12 to 13 LPS, liter per second in that borewell. Na? So during our study, we found that most of the springs are like perennial springs, but the discharge is very less, especially during lean period. And this spring, actually, there is one video how this is a depression spring, and the water, the discharge is around 2 to 3 LPS, this one, and it is continuously flowing. People call this spring as a magic spring. Why? Because, and in that, this is like around 50, 60 households are dependent on this spring. They used to come and fetch water. Na? So that in that area, the local people call this water source as magic pond, because continuously, even if they fetch water, people, especially during morning, the water remains as it is. I mean, it doesn't decrease, nah? So it has got a good aquifer system in that for this particular spring. So they were like, they don't know those kind of things. So they used to think that, oh, this is magic, nah? Even if they continuously fetch water, it doesn't get decreased. So they used to call that a magic pond. So we found that most of the springs in that say in that study area in Kohima district is mostly of depression spring, and around 29% fracture springs. And some of the springs are like depression comes fracture springs, which comprise of both depression and fracture type of springs. And the discharge, most of the discharge, as I've mentioned earlier, is in 7 magnitude, where the discharge ranges from 10 to 100 milliliter per second. And we also did, I think Sir has already explained the vulnerability assessment. So we did a very simple vulnerability assessment of those 100 springs using weighted average method. And then we have considered, I think Sir parameters is a bit different, but we have considered this 8 parameter for the spring vulnerability assessment. Like we consider spring discharge variation across the year, reduction of spring discharge over a period of time, average spring discharge magnitude, landslide susceptibility, changes in LU, LC in the spring area, dependency of spring, availability of alternate water sources, and slope gradient. And we found that all the springs fall under in this moderate vulnerability. I mean, the springs that we have invented. And we did some delineation of spring shade in one area, just to locate the spring shade area and the spring recharge area. We also did some study. So in Nagaland, or say in some hilly state, you can see like if there is a big mound or in that particular mound, and if there is no settlement in that, there used to be lots of springs. So we found some cluster of spring in one mound. We call that this mound as Mount Turugu, and in this mound we found like around 16 springs. So around this mound there are 4 or 5 villages, like big villages, and then there is also a district headquarters. And all these springs are the main water source of those villages and the town. And so we found that this mound is very important. So I think if you can find some cluster of spring in some particular, you can go for a big project type. And then we did some this analysis, and then demarcated the recharge area, and then like slope analysis, like in that particular area, how many trenches can be constructed. So this exercise was carried out. And we so in that particular mound, there we found that there is a huge spring discharge, but the people in that area, they don't utilize it. So we found that during in lean period, the discharge of this spring was 4.59 LPS, whereas the present spring source where PH is supplying water, it was just I think 1.5 LPS. So if PHC or the government can develop this particular spring, I mean the demand supply gap, it will be catered in this. I mean, for the if they develop this spring, they can easily cater the needs of the people. So through those studies, we found that I mean we have identified some critical springs where it needs some spring shade management in those springs. So around 34 numbers in those 4 blocks. And water quality, most of the springs like is like within permissible limit, but except in some few springs, there is high iron concentration in some area and high manganese. So the next lecture will be covered by Sausar. So I think chemical part he will explain in detail. So usually in Nagaland, like there is high concentration of manganese and iron because of the geological formation also. So yeah, as I've mentioned earlier, that springs are predominant of depression and fracture types, and discharge of the majority is very low, but perennial. So coming to the next state, that is Arunachal Pradesh. So Arunachal Pradesh, like geologically, the rocks ranges in age from Archean to recent, and majority is like consolidated crystalline. But you can also find some semi-consolidated and unconsolidated formation. And you can see like there is this gravelly sand, which is the aquifer zone, we call those, and silty clay. We can see some section. If you go in some rock section, you can find this kind of section. And like this is some 2D aquifer disposition of alluvial and Siwalik aquifers in Arunachal Pradesh. So we can see that the huge this gravel and sand bed exists in those area. So it has got a high aquifer potential in those area, and mainly from West Kamen, East Kamen, and Papumpere districts. And this is another section in Papumpere district. So in like when we see like spring hydrogeology in consolidated formation, the rock types are mainly of gneiss, schist, quartzite, and some basic and exit igneous rock. And type of springs mainly in this formation is of fracture type of spring, and the discharge, as I've mentioned, is mentioned in that slide. It ranges from 32 to 64 meter cube per day for gneiss, schist, quartzite. So this study was carried out by my senior officers. So he did this study during 2013-14, yeah. And semi-consolidated formation like sandstone shale, and unconsolidated formation like gravel sand. So in unconsolidated formation, like mainly contact type of springs, as I've mentioned, as I've shown earlier. That's gravel bed and then clay sealed bed, in between that two zone. So you can see, you can find a thermal spring at Dirang also in Arunachal Pradesh. And this is spring in East Siang district, where there is a huge spring line at Miram village. So it has got a huge discharge. And these are mostly contact type of springs. Yeah, this one is from Kimin sandstone. So this one is in Papumpere districts. And let's say this is not a naturally occurring spring, but just to show like contact spring. So this is like a clay bed, and then above that is a gravel pebble bed. So in contact between these two zones, there is water oozing out. So I'll just show you some photographs how springs exist in different different area of northeastern states. So in Tripura, it is underlain by lower tertiary to recent formation, and through some survey study, it revealed that the presence of 3 to 4 major aquifer encounter within the depth of 250 meter in the valley. And yeah, I'll just show the map. So it is the geological formation comprised mainly of alluvium, Dupitila, Tipam, and Bokabil and Buban formation. And the groundwater potential is low, moderate to very good in this Tipam formation, and then limited potentially in Bokabil and this one, Buban, yeah, formation. This is some panel diagram showing subsurface geological towards this Kaila, Shalhar, and Chamuna Valley. So this yellow indicates the sandstone, and then the gray part indicates the shale, which is the impermeable strata. So our colleague in this Agartala office, they have done some spring studies in this in this area. So they found that the spring exists in this straight line, which is in the hilly section of that area. I think some of you are from posted in Agartala, right? So they must be knowing much more than me. So in those areas, like people are also very much dependent on spring for drinking purpose, as shown in this photograph. Like these are, I'll just show some field photographs. So these are the actual field conditions. They have done this. They have monitored, and then they have collected some sample. So when we compare with this Menzer's classification in that particular, for those springs existing in that area, most of the springs exist in this 7 magnitude. So we can see that in northeastern India, most of the spring discharge is not that high, but it is in the lower part, that is in 7 magnitude. So Assam actually, most of Assam is covered by alluvium and sandstone. I mean, yeah, Brahmaputra Valley is mostly of alluvium formation, underlying by alluvium formation. In some part, you can find granite, gneiss, quartzite shale also. So this is the hydrogeological map of Assam. Assam, the hydrogeologically can be classified into unconsolidated formation, semi-consolidated formation, and consolidated formation. Majority is covered by this unconsolidated formation, as shown in this map. And the unconsolidated formation is mainly from Brahmaputra and Barak Valley, and semi-consolidated formation mainly in Kachar and North Kachar Hills district, south of Karbi Anglong and parts of Upper Assam, and consolidated formation in Karbi Anglong, Kamruk and parts of Western Assam. So presently, one spring study is going on in Dima Hasao district. So these are the main water source of PHE, PHE. So they are doing some studies in this, and maybe next year they will come up with some management plan. So in Assam, I think only in Dima Hasao or Karbi Anglong, those are hilly regions, so you can find springs in those areas. Here, very less spring. I mean, in the plain area, you won't find much spring. So Mizoram is like mainly comprised of this quaternary and tertiary group of sediments, and the rock types exposed in Mizoram belong to the Tripura, Mizoram, Miso, Meo-geosynclinal facies of the Sumatra Basin of Assam. And the hydrogeological water-bearing formation identified in the area are mainly of alluvial formation, valley fields, or sandstone of tertiary formation. And springs in 2014-15, some few springs were studied in this Lungle district. And yeah, these are some of the field photographs. So it's almost similar to Nagaland springs, where the discharge is very less, and then the formation also very much similar to Nagaland also. So these are some field photographs, and in that particular area, 16 springs were monitored in Lungle district, and it's under 6 magnitude of measures classification. And Manipur, we have not done any spring studies in Manipur because our office is not in that area also. And then, but when we see the hydrogeological map of Manipur, we can see that except in this Imphal Valley, the rest are like comprised of Suma, Beryl, Disang, and metamorphic complex. And most of these surrounding are of hilly region, and the people there are also very much dependent on springs. But we have not done any spring studies. Yeah, so that concludes my presentation. Yeah, if you have any queries or if you want to ask. Yeah.
Thank you, sir. Very good presentation. But we need to share, sir, your presentation.
Yeah.
Actually benefit for our Northeast state.
Yeah, sure. Yeah, I can. I think for the
Can we make questions? I think most of us are still not clear with types of springs.
Okay.
Contact, depression. We have seen the pictures, but we cannot. If we
Oh.
go on actual field or we see any.
Yeah. Actually, I thought sir has already covered that part.
We have understood, sir.
Ah.
But still, it's not clear the types of like. This is contact. This is depression.
Okay.
This is fracture.
Depression usually like.
Can you show me? Sir, I'll just go there.
Yeah.
I'm okay if I question
Yeah.
you, sir.
Okay.
So suppose this is a treetop. So as you said, sir, this is the aquifer.
Yeah.
If water comes out from like here, it's fracture.
So in sketch, say, I'll just show you. In sketch, you can say that. Okay, this is. You mean that one spring is coming out from this point, nah?
Yes.
And then so it depends on that particular point, nah? So say if it is like fractures, say if this area comprised of hard rock area, and then if there is, the weather zone is also, very shallow, or it doesn't have much soil cover. That means, and if in that particular point, if you find that the water is coming out from those fracture zone, that means it is fracture spring. Then if you find that the water is just like this entire, this entire is covered by weathered or this soil cover, and then the water is just spin out, where you can't find some hard rock formation. So it is a depression type of spring, because like from here, then here you can, there's undulatory formation, topography. Yeah. Formation of. So for contact spring, you can clearly see like if there is two different type of rock formation. One can be of permeable formation, the
Can
other.
we figure out with our naked eyes?
Yeah. But in actual field condition, it's very sometimes it's very difficult to identify also. So you have to go to the point where the water is coming out, and then check the surrounding.
So for different springs,
Yeah.
the measures will be also different. Like
Yeah. So identifying the recharge area, it also depends on the type of spring. Say fracture spring. For depression springs, though, it's very easy to. Comparing to other type of springs, it's very. It's easier, much more easier because there is some. I think yesterday whether sir has covered that topic or not, but there's some thumb rule for different type of springs where the recharge area exists. Located, right. For a depression type of spring, we can say that it's on the upper reach of that particular point. For fractures usually on the lineament zone or on those up, it can be. So it depends on the geological structure also, but mainly on the this one lineament zone or on the enscrapement of that geological bed, Yeah. For contact spring, so say for a contact spring, the recharge zone can be, say if this is a bedding plan, and then the recharge can be in this area also for a contact spring, or maybe for fracture spring also. So it depends on different area.
Sir, one question.
Yeah.
Sir, myself also groundwater background.
Okay.
Okay. Sir, now we are studying on electromagnetic resistivity survey for deep table.
Okay.
So that's up to give us 600 meter below
Okay.
total graph like this.
Okay. Yeah.
So now we are wanting to identify where is the source point from starting
Okay.
for this hilly topography.
Yes.
And when we identify the basic source, this is the line for exposing the spring.
Okay.
Then we will recharge on that point.
Yes.
So how will total cover is that point? And by this study, can you analyze anything?
Like how much area the recharge can be?
No, not that.
Then.
One point will be there,
Yeah.
for flowing the water, main sources, and that's area may be
Okay.
spread. So if we identify the dead points
Yeah.
where water is accumulated,
Okay.
and after that point that is flowing on one point, that may be 2 meter, that may be 200 meter
Okay.
from basic source, and total area will be identified. If we study on the electromagnetic resistivity survey
Okay.
on that points or that area, then total area will be identified, and on that point we will recharge
Okay.
for extra or constant flow for whole year. You are saying also that in total northeast during lean period there is no water,
Yeah.
maximum point.
Yes.
Then we can benefit on that point if we identify exactly.
Yeah.
Can you say that type of field study will benefit us? Just I can show you.
In regard to the spring study, you mean
This type of study up to below 600 meter.
600 meters?
Yes, near 1800 feet.
Okay, but
Electromagnetic resistivity survey.
yeah. So for groundwater study, that information is very important. It's very helpful. But when it comes to spring study, spring study usually it's mostly of shallow aquifer. So like
Shallow aquifer, but when spring comes, that
Yeah.
groundwater exposed on some points
Yeah.
for free flowing that water.
Yes, artesian well you mean?
That may be a line. Artesian is a different issue.
Yeah.
Because artesian is man-made or artificial. Artesian is artificial.
Yeah. Where the outflow? Yeah, if you
Artesian is artificial.
Yes,
Because there is some flow by palm water or.
No, artesian means like naturally the water is coming out, but through artificial structures. Yeah.
When it's ma'am said that depression spring, contractual spring, when there is a fracture layer, then
Yes, yes.
That's fracture layer.
Yeah.
That is contractual.
Yes.
When is a depression, then it deposit the water there. That is a depression. Simple we can say.
Mm.
And single, because groundwater is a vast subject.
Yeah, yeah.
Hydrogeology.
Mm.
So a lot of subject is included there.
Yes, yes.
So for that, sir, I am saying that type of study, how will get benefit if we identify that total catchment area for spring.
Yeah.
If we study on the 4, 5 or 6 point
Yes, yes.
total electromagnetic resistivity survey,
Yeah, yeah.
then if we identify that, then we can get benefit.
Yeah, yeah, definitely it will give up some idea like whether that particular area has got like the potential to receive the structure that we have under the
Just see, sir.
yeah, yeah.
Where is water? Matlab, this blue color is only water.
Okay.
Other is not. That is a purchase type pond. We can say this type of
That is subsurface data, right?
subsurface.
Okay, okay.
Ground, spring also subsurface.
Yes, yes. Spring aquifer also subsurface, yeah, but it is coming out
Maybe
naturally.
below the 2 meter below, or that may be 100 meter below.
Yeah, yeah. So you can plan out some artificial recharge structures based on your data also. Yeah.
Okay. Thank you, sir.
Yeah.
Please kindly share.
Yeah, yeah, sure, sure, yeah. I think I have taken extra time. Thank you. Yeah.
Sir, you have shown the inventory of northeast states, all the spring numbers and all.
Yeah,
Can we get the data also?
yeah. It's
The
all these
spring
that.
names or the village names.
Yeah, yeah. It's in our report only.
इनके पास नहीं होगा, CGW के पास नहीं होगा, नहीं होगा,
नहीं,
क्योंकि ये अभी तक सेंसर चल रहा है ना, वो एक्चुअली दिल्ली के पास होगा, मतलब आफ्टर दिस सेंसर, अभी तक हाँ, स्टेट गवर्नमेंट के पास अपना अपना होगा, हाँ, मतलब अभी पूरे नॉर्थ ईस्ट का आपको मिलेगा दिल्ली के पास, क्योंकि दिल्ली के पास ये होगा और इन लोगों के पास होगा, और सुमन तिवारी सर के पास, और समन राउत सर के पास, इन लोगों के पास ये लोग ही सब मॉनिटरिंग कर रहे हैं, और ये सब उल्टा सीधा काम हो रहा है, एक तो उल्टा सीधा काम हो रहा है, क्योंकि वो लोग जिस तरह काम करा रहा है ये सही
That's
नहीं
still going on. Yes, sir.
But like, if you want to check, some.
इन लोग मतलब
You can get in our website the report, na? Everything is published.
हर मतलब मैं इन सर लोगों के साथ एक्चुअली मैं इन लोगों का कांटेक्ट में भी हूँ, मतलब अगर त्रिपुरा में तो सबसे वन ऑफ द बेस्ट आपका एक साइंटिस्ट था, उनका नाम क्या है, राजाराम पुरोहित सर भी था, उन्होंने मतलब हर स्टेट पे 30, 40, 50 करके वो लोग आइडेंटिफाई किया है, बट पूरे स्टेट का वो लोग नहीं कर पाए, पूरा स्टेट का कर नहीं पाए, सेंसस के बाद मान लीजिए 70-80% आएगा, पूरा कभी नहीं आएगा, क्योंकि सेंट्रल गवर्नमेंट जिस तरह हम लोग को स्टेट को सपोर्ट कर रहा है, बोल रहे हैं 100% सेंट्रल असिस्टेंस, बट कुछ भी असिस्टेंस नहीं है, मतलब स्टेट गवर्नमेंट के पास इतना पैसा नहीं है, वो जाके फील्ड में एक स्प्रिंग पे जाने के लिए कम से कम पूरे दिन भर चलना पड़ता है, पैदल चलना पड़ता है, तो कौन इतना लेबर देगा, कोई ऐसा भी है, कोई रिवर क्रॉस करना पड़ रहा है, वो किसी को मतलब इतना पानी क्रॉस करके इसके बाद जाना पड़ रहा है स्प्रिंग को आइडेंटिफाई करने के लिए, और दिन भर इतना चढ़ाई उतराई करने के बाद जनरली गवर्नमेंट एम्प्लॉय और कोई पर्सनल रिसोर्स ऐसे इनिशिएटिव नहीं ले रहा है, बट टाटा और आपका ये टाटा का CML और एक दूसरा एक टाटा का कौन सा है नोएडा, ये दोनों मिलके कर रहा है, मतलब बहुत कुछ कर रहा है, तो इसलिए आपको इस सेंसस के बाद कुछ पता चलेगा मतलब कितना है, और इसके बाद जहाँ डिस्चार्ज हाई है उसको आप पॉइंट आउट कर सकते हैं, इसको सर्वेट कराने के लिए, अदरवाइज गवर्नमेंट ऑफ इंडिया पूरा नहीं लेगा, जो बोल रहे हैं ना ये लोग ड्राई स्प्रिंग को भी हम सर्वाइव करा देंगे, वो नहीं होगा। ওইটা ন্যাচারাল প্রসেস উইদাউট কি মানে ওইটা হার্ট প্রেসার হোক মানে প্রেসার হোক ওয়াটার প্রেসার হোক এটা ন্যাচারালি ফ্লো এবং এটা আস্তে আস্তে যখন ড্রাই সিজন হয় এটা ড্রাই হয়ে যায় আর বৃষ্টির সময় এটা তারা বৃষ্টি হয় তাই এটা বিশাল সাবজেক্ট এটা বিশাল বড় সাবজেক্ট এটা ডায়নামিক্স থার্মোডায়নামিক্স তারপর জিওলজি জিওফিজিক্স জিওকেমিস্ট্রি মানে 7-8 आइटम सब्जेक्ट मिला हुई से ग्राउंड
अच्छा स्प्रिंग का इक्विपमेंट नीचे ही होता है
हाँ स्प्रिंग को नीचे होता है नहीं मतलब अब सरफेस आ गया कॉन्टेक्स्ट सरफेस के ऊपर कैसे होगा
नहीं कॉन्टेक्ट ऊपर में तो वाटरफॉल होगा ना नहीं कॉन्टेक्ट स्प्रिंग का तो ऊपर जो रहता है
कॉन्ट्रैक्ट स्प्रिंग मतलब आर्ट सरफेस के नीचे हाँ इसमें जिस लेयर में फ्रैक्चर को उससे आइडेंटिफाई हो जाए मतलब उसको फ्लो होता है
डिप्रेशन में तो होता है सर
डिप्रेशन तो नीचे ही ऐसे पॉइंट से निकल जाएगा
जैसा फट गया ऊपर में ना
और नीचे से निकल जाएगा मतलब पानी फ्री फ्लो होगा सिंपल सी बात स्प्रिंग मतलब एक तो मतलब उसका बॉडी से भी स्विप करके गिर सकता है और ऐसे फ्लो हो सकता है डायरेक्ट फ्लो मतलब ऊपर से पानी गिरेगा फ्री फ्लोइंग
আমরা তো স্যার অনুভূতি যেটা
এটা তো আমরা গেছিলাম ভিজিট করছি
झरना है बेटा है
ये देखिए ये इसमें वाटरफॉल जो है इसमें दो पार्ट इसके साथ मिक्स है जैसे कोई वहां पर है डिप्रेस्ड एरिया है उसमें बारिश का पानी डिपॉजिट हो गया वहां से पानी आ रहा है साथ में ये पूरा मान लीजिए पूरा बारिश पूरे साल होता नहीं आप उसमें देखना है पूरे साल ये पर पानी नहीं है तो ये ड्राई सीजन में इसमें पानी नहीं गिरेगा मतलब ये कम हो जाएगा और तब जो फ्लो कांस्टेंट रहेगा मतलब ग्राउंड वाटर से पानी आके इसके अंदर गिर रहा है इसके बाद ये पानी फ्री फ्लो हो रहा है और उसका डिस्चार्ज जब उसको डिस्चार्ज मेजर होने से आपको पता चल जाएगा तो इसके अंदर स्प्रिंग है कि नहीं इसका सोर्स किसी दूर पे हो सकते हैं बट 6 महीना में 7 महीना मान लीजिए मेरा बारिश होता है बाकी 5 महीना नहीं होता है अब फरवरी मार्च पे इसका पानी कंटिन्यूअसली फ्लो हो रहा है मतलब इसके अंदर स्प्रिंग मतलब ये अनडाउटेडली इसके अंदर स्प्रिंग है अब इसका सोर्स पता करना चलेगा कहां पर ये सोर्स है अगर में मतलब मुझे तो पानी खत्म हो जाएगा ना बारिश का पानी अंदर से तो पानी छोड़